Good afternoon, everybody. My name is Hani Abdurrahman, and today I'm going to take you through the MLOps project of my group, Group 12D. And our project involves monitoring deforestation using satellite imagery. We try to develop a model, and I'll take you through what we have. First and foremost, we are trying to set up paths, okay, and fetch the data. So what this means is that we are trying to fetch the data which is within the Kego, which is located within Kego. So we are trying to first import this data from there, and of course we are going to use this data within our model. We're going to, just like you can read from the code, we shall be data source mapping. So this is now where our data is located, and then we shall create two repositories, that is the input repository and the working repository. So the input repository is going to contain the data set, the data that we shall be using, as well as the working repository. But for the model is running, we shall be working with the working repository. Uh, of course, in order to work with this machine learning project, we shall have to import some libraries. One is NP, which I've imported as NP, and this is used for arithmetic calculations, mathematical calculations. Pandas is used for what is it called? It's used for data analysis. Of course, in this case, we're using that data set, so we need to analyze this data. So, uh, if you go down in the code that I've given you here, we are trying to obtain the file. We're trying to list the file within the directory that is given. So we are trying to within the input directory, we're trying to list all the files with their names, and this will be printed one by one, creating a long list. And this is what we shall come up with. So, uh, now we are now going to again import libraries now to now work on the model. As for the other case, we are fetching the data. So in this case, we're going to import NumPy. I've given it a reason. TensorFlow, when you're trying to build a model, you need to use TensorFlow or MlFlow. And then you're going to also get some libraries, some modules from within TensorFlow, such as the Keras library. And the reason for this is that we shall be able to maybe bring in metrics which include precision, determine precision, accuracy, recall. And then we shall also use shall use this Keras library to gain the train split data, which is going to split our data into two sets. One is for testing and another for validation. So we're going to use the deep learning model that has been discussed in Siniva's paper, which is the ResNet 50. And this deep learning model, we're trying to import the pre-trained model. This ResNet 50, it is used to extract features, and then you're going to label the labels. So we're going, which are the labels, the data frames from the data sheet, from the data sheets. So we are trying to prepare the data set. We're trying to prepare the data for the data frames of deforestation and data frames of pollution. Then we're splitting them into training and validation, just like I've told you. And then we're adding extensions to the image file names, which is the .jpeg, to ensure that these are actual images and to work with these images. Here, we are now trying to do what I call augmentation and normalization. The image data generator is used to rescale, okay, the images that we have, okay, and it comes from the Keras module. And for this case, we shall involve augmentation, which means expanding on your data so that you can train your model in a better way. And then normalization, you are trying to ensure that the values that you're attaining are fitting within a certain range, within a certain scale. Okay. So now we're also setting the path to the dataset directory. So as above, you can see we have created the function to create the generator. Then you have set the path to dataset directory. Okay. Where this model now will be linked to the dataset. Then we shall create dataset generators for training and validation for the both of them. This is now from my paper, the paper that I was assigned regarding deep learning and then trying to monitor deforestation over time with at a 10-meter resolution near real time. And it actually shows you the features that are already being implemented in the previous slide: augmentation, normalization, trying to, as you can see from the Sentinel-2 L1C, we're trying to remove the cloud mask, remove the cloud shadows, all of these things that create noise. And then from the other side, which is the Sentinel L2, we was used for the annotation. So we don't have to pay much attention to that. We shall focus on this. You can already see how we are going. Then here we are trying to build the model. As you can see, we are now adding dropout layers to the model, and then we are trying to create the final model from these dropout layers. Then we shall freeze the model based model layers. The reason we are freezing is because during training, the initial training, we don't want to use these base model layers. We're going to freeze them, and after the initial model training, then we can apply this. Then we shall compile the model to create a full set. Now training the model. Now you're going to get the training data set. I'll give it to the model. However, takes a lot of time, and we're currently trying to work on it. It has already been taking me 3 hours. But eventually we shall be able to obtain what we shall need. And then we are importing the image class from the Keras module. And then we're trying to load and process the images and make a prediction using the model. After processing the images, now we shall feed the images into the model, and then we shall obtain predictions. So these predictions will be loaded, and these are the results we shall get. This is the learning pipeline orchestration. For this case, we are trying to incorporate Kubeflow from the Google Cloud platform, and which is going to run on the Kubernetes engine. And we are trying to integrate this we try to incorporate this with our project so that we can orchestrate to allow pipelining. Test images. These are the test. Now you've trained the model. Now you want to test them. Now test the images. So what does this mean? We're going to get 5 random images from the dataset that we already have, from the from the from the datasheet we already have, and we shall run this, and we shall try to obtain the results we can get. And this is what the come. They will be printed as deforestation probability that has occurred. Which is going to be our final result. I think I'm done. Thank you so much. This is Haned Rahman. Thank you.